So today I'm going to show you about adding and subtracting fractions. The key idea that nobody mentions to you when you start learning about fractions is that you can't work with different sized objects. So for example, if I offered you a third of this cake, but I had a third of this cake, that just isn't fair. So before we do anything, we need to make sure that whatever we're working with has exactly the same size starts. So this cake and this cake are both the same size. This one has been split into 3 equal pieces, and I've kept one of those pieces, so I've got a third. This one has been split into 5 equal sections, so that's my denominator, and I've kept 2 of those, so I've got 2/5. And what I'm going to do now is work out, if I add those 2 together, how much of the cake I've eaten in total. Now at the moment, because we've got different size base pieces, they're really hard to compare. So what I'm actually going to do is re-chop both cakes so that they end up with the same size sections. And this is how I'm going to do it. I know that 3 and 5 are both in the 15 times table. So for instance here we've got 3, 6, 9, 12, 15 and 5, 10, 15, 20, and both of them are factors of 15, so 15 is a multiple of both of them. Now to be able to compare fractions or even work with them in any form when adding or subtracting them, we need to change them into the same size pieces, and we're going to change them into 15ths because again 3 will go into 15 and so will 5, so it's easy to chop them up into the same size pieces. So I'm going to rewrite my third as 15ths, and I'm going to rewrite my 2/5 as 15ths as well. And I'm going to do that now visually for you. So I've got thirds, and what I'm going to do is put a line down here. So now I have 15 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now notice that my third, because my third's been chopped into smaller pieces, I have 1, 2, 3, 4, 5 of those. Notice that my third is going to be turned into 15 chunks by timesing by 5, so I have to treat my denominator and my numerator the same to keep them in proportion. So I'm also going to times my numerator by 5, so I end up with 5/15. So let's check that. Is my third now worth 5 pieces? 1, 2, 3, 4, 5. Perfect. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I've definitely got this right. Now I'm going to do exactly the same with my 2/5. To change it from fifths into 15, I have to do 3 times more cuts than I already have. So I'm going to cut along this way. So now I have 15 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I've made 3 times more cuts this way. I need to make 3 more times cuts on my denominator and my numerator so that my original fraction stays in the same proportion. So I end up with 6/15. So let's check that. Did my original 2/5 get turned into 6 chunks when I divided it 3 by 3? Yes, it did. 1, 2, 3, 4, 5, 6 out of 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, they both have, those cakes are split into exactly the same size amounts. So each of their chunks are identical. It's just one has slightly less than the other of those chunks. Now that we have the same denominator, we know we have the same size chunks or the same size pieces. So now we can compare them by bringing them all together. Now, this doesn't mean that it's out of 30. Do not add the denominators together. Look, we're going to take these 5 bits and include them on here, like so. I've included my 5/15ths from my original cake onto my other cake, and now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 15ths in total. So just remember, when you're working with denominators and you're adding or subtracting, you keep the denominator the same. We haven't cut our cakes into 30 pieces. We've cut them in 15 pieces, and then we've placed some of the 15ths from this cake onto the top of this cake. So 5 plus 6 made 11, and look, as I said before, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces. So 11 15ths is the answer to 1/3 plus 2/5. And that's how it's done. So just to recap, without the diagrams, this is how you do it. The first thing you need to do is look at your denominators and work out what number both of them will go into. So you're looking for a multiple of both 3 and 5. So I would write both the times tables down. 3, 6, 9, 12, 15, 18, and 5, 10, 15, 20. Well, the only number that's in both those is 15. So I'm going to rewrite my third into 15ths, and I'm also going to rewrite my fifths into 15ths. To go from 3 to 15, I need 1, 2, 3, 4, 5 times more cuts. So this one chunk is going to be cut into 5 times the amount of pieces it already is. So I'm going to get 5 15ths. And this one, to go from 5 to 15, I'm going to have to make 1, 2, 3 times more cuts than I started with. So I'm going to have to turn this into 6 because it's been cut up 3 more times. So I end up with 5 15ths added to 6 15ths. Now remember, most importantly, do not add your denominators together because everything's been cut up into 15ths. We're not cutting it up into 30. We've got 2 separate items cut up into 15ths. They've not been cut into 30 pieces. So it's out of 15 still. And then you just add the numerators, which give you 11 15ths. Because I've got a prime number on top, and this prime is not a factor of my denominator, I cannot cancel it down any further. So I know that this is simplified. Start it from there. Okay. Now, if you'd had an answer that came out something like 4 over 12, you must remember to simplify. So I know that 1 times 4 is 4, and 3 times 4 is 12. Cancel through any numbers that are identical on top, and that tells me that 4 12ths is exactly the same as a third, and I'll show you that now. So notice that 4 out of 12 parts is exactly the same amount shaded in as 1 out of 3 parts. They are identical amounts shaded in out of identical size pieces, so base pieces, so the actual cakes that you took them from. If I had 4 12ths or 1/3, I would end up eating the same amount of cake. They are equivalent fractions, and you often see this in exams. They are equivalent.